Hi, my name's Steve Ansell. I'm from Mayo Clinic and wanted to give an update of some of the exciting and encouraging results that are coming out of the Waldenstrom's workshop that has just been taking place in Prague. Two main areas of really significant findings and interest, one being the biology of Waldenstrom's macroglobulinemia and the other being the treatment and ways in which we can get better results for patients. So firstly, talking about the biology, a lot of work had been done in the past of really understanding the genetic script, if you like, that's within the cells, but that's now translating into understanding more and more about how that script is turned into a playbook, as it were, for each cell. And the cells are actually then able to respond to certain genes that are switched on versus others that are switched off. How that might be important is that we're understanding that some patients with Waldenstrom's have more of a B cell appearance in their way in which the cells are behaving, and others have more of a plasma cell behavior based on their genomic regulation and how the genes are working. So that's actually really interesting because as those cells change, they interact with the bone marrow and the other cells around them, and there are various proteins and inflammatory markers that are going back and forth that allow those cells to actually look more like B cells or more like plasma cells. Why that's important overall is that we might be able to interfere with that reading of the code and then also with that inflammatory environment, which may actually result in new treatments for patients in the future. Talking then about treatments in general, now a focus on established treatments and both chemoimmunotherapy, so a chemical in combination with an antibody. Those results have been very established. The use of drugs like bendamustine with rituximab have been established treatments, and long-term follow-up shows really good results with that kind of therapy. Similarly, blocking some of the key pathways with what are called BTK inhibitors, drugs like ibrutinib and zanubrutinib and acalabrutinib, those have been very effective. And recent data is now looking at utilizing all of those in combination and showing excellent results where patients have a very good result and get into a deep remission with no detectable disease. And the question now is, with follow-up, are those patients going to be those for whom the disease never comes back? So are we a step closer to a cure? That's really our hope. And I think the data from both biology and treatment suggests that real progress is being made.